Have you ever wanted to fly one of these planes? Technically you could in a simulator. Okay. You know what would be nice? If I could fly a real plane. Yeah, never mind.
And that's when it hit me. The best idea I ever had in my entire life. That's the worst idea you ever had in your entire life.
What if I made my own plane? I will be basically making an RC plane similar to the Aeroscout trainer. However, its difference is in its size. This is the design, codename Kestrel. Kestrel will be made from carbon fiber rods for its great strength to weight ratio, various metals due to its cheap cost, various 3D printed materials such as carbon fiber infused PETG for key structural parts, and PETG for its temperature and impact resistance. The majority of the aircraft also has a honeycomb-like infill to save on weight and print time. Here's an example. To keep this aircraft more stable, I have implemented a 3-degree wing dihedral to stabilize the aircraft. You can see wing dihedral commonly used on civilian aircraft such as this Boeing 777. I've also given the wing a 5-degree twist, also known as a washout. This is to ensure the outer control surfaces on the edge of the wing stay functional and do not stall at high angles of attack. A stall occurs when the angle of attack becomes so steep that the airflow detaches from the wing, causing a sudden loss of lift. As you can see here, the root of the wing is beginning to stall. By adding washout, the control surfaces at the edge of the wing are the last to stall. This allows the plane to be more controllable even as the root of the wing starts to lose lift. Since this model is the total sum of my experience in SOLIDWORKS, there are deep core issues with the current model. For example, some areas are not perfectly symmetrical, like the wings, and some of the control surfaces are not perfect. We can disregard these tiny imperfections in the model, as they would most likely be overshadowed by the margins of the slicer and the 3D printer. I have left out many features like folding landing gear and nose wheel steering in order to save on time modeling and wait for the maiden flight. Once I am confident Kestrel can fly, I will be recreating the model so that I have a better foundation and include all the features. Another major compromise that I made when designing is with the twin rods. I originally wanted carbon fiber, but they only came in 16-inch sections and costed 10 times as much compared to the alternative. That alternative being using metal rods that came in the proper length that I needed. Kestrel will have two 16-inch propellers with an 8-inch twist in a counter-rotating configuration, powered by two 5065 brushless motors. Everything will be controlled by an H7 series flight controller. So you may be asking yourself, what's next? Here is a roadmap of all the things that I need to do. My next steps are modeling the axis doors and dividing the model so that it can be printed. I estimate that it'll take around 2 to 3 weeks of non-stop printing. All the blacked out boxes are secrets for the next video. Thank you so much for watching. If you have any questions or suggestions, please leave a comment down below. I'll see you on the next one.